So this is, now we're going to move on to the last part, that is the conditional expectation. So after this, we're going to get into the stochastic process. Okay? But the foundations are very important for any study. Okay? So all we are talking about right now, or discussing right now, they are all foundations. I hope everybody have a very strong foundation before we really get into Markov chain. It's okay? So now let's talk about conditional expectation. So what is conditional expectation? What is this? And what is this guy? This is a conditional expectation. This is not. Okay? So this is a conditional expectation in the discrete case, because we have discrete, right, equals to something and a probability mass function. If x and y are discrete random variables, so the condition x and y, they are discrete random variables, then the conditional probability mass function, so conditional, this is a conditional probability mass function, x given y equals to y, okay? So if you have conditional probability mass function, so you have joint probability, right? Then divided by the marginal y equals to y, right? So this is p joint xy divided by py. So this gives you the conditional probability mass function. This is the definition of conditional probability. This is what we discussed before. But this part is the cumulative. Okay? Given the condition, given y, and you want to find out what's the probability that this random variable less than or equal to x. Given y, random variable y equals to y, what is the conditional probability, or cumulative probability of x less than x? So this will become a less than x. You're going to add all of them together, given that y equals to y. Okay? So this is the cumulative conditional distribution. The conditional expectation of x given y is defined as follows. This is the expectation now. Okay? Given y equals to y, now you have the x. Now you're calculating the expectation of this x. So this is called conditional expectation. Okay. Now, in order to calculate conditional expectation, we have x, and we also have conditional probability here. Probability of equal to x, and given y equals to y. And also you have x, what is the value of x? And then times the probability that you equal to x given y. So in this way, you just write this into this, actually here, right? Over here. So you have x multiplied by the conditional probability mass function. You will be able to get the conditional expectation. Okay. So again, this is a conditional probability mass function because it's discrete. This is a cumulative conditional probability. This is the conditional expectation given y equals to y. Now, now let's have a look at an example. If we have x and y are independent Poisson random variables, okay, with respective means lambda 1, lambda 2, calculate the conditional expected value of x given x plus y equals to n. So my first question is, if x is Poisson, y is Poisson, x plus y, what is the distribution of x plus y? Poisson again, right? So we know that what is the probability x plus y equals to n, and what is the distribution? Is it Poisson? So let's do it. So we are going to get expectation x given x plus y equals to n. So we are interested in this value, right? Now, let's first calculate what is the probability that x equals to k given x plus y equals to n. Okay? Yes, so this will become probability x equals to k, x plus y equals to n, divided by probability x plus y equals to n. So far it's okay, right? So this is a definition of conditional probability. And we also know that x plus y is Poisson. X plus y is Poisson. And we know the rate for x and y. So what is the Poisson for x plus y? What is the mean? Lambda 1 plus lambda 2. So what do we have here? This will become probability. So if x equals to k, okay? Now what is y will equals to? M minus k. But they are independent. So here they are saying x and y are independent. So what you can do is just add a probability, separate these two, and then divide by probability x plus y equals to n. Okay. So this will equals to exponential minus lambda 1. Lambda 1 k divided by k factorial times exponential minus lambda 2. Lambda 2 n minus k. M minus k factorial. Then what is the denominator? Let's put denominator in this form so that we add a minus 1. So this will become exponential minus lambda 1 plus lambda 2 because we know the new rate or mean. Lambda 1 plus lambda 2 power n divided by n factorial. Okay, let's rearrange. This will become, this is inverse, right? So why we have inverse? Because it's a denominator. I just write them together so that I have to add an inverse, okay? So because of the inverse, but n factorial is inverse, and we inverse it again, then it's flipped to the numerator. So this will become n factorial divided by k factorial n minus k factorial. Then times lambda 1 k and lambda 2 n minus k divided by lambda 1 plus lambda 2 n. So lambda cancelled, exponential part cancelled because you have inverse over there. So they cancelled, become 1. So what is this part? This part is actually n choose k. Okay, lambda 1 plus lambda 1 plus lambda 2 k, and then lambda 2 over lambda 1 plus lambda 2 n minus k. Everybody agree? Because you have the denominator m minus k, this is k, so if you multiply them together it's actually n. So that's what we got here, but the numerator is lambda 1 k, lambda 2 n minus k. So what is this? Yeah, this is binomial, right? Is it a binomial distribution? So what is a binomial? Binomial, what is n? Right, n. And what is p? Okay. So since we know it's a binomial, and a binomial, what is a binomial expectation? NP. So far, and we got this expectation x given x plus y equals to n equals to n lambda 1 plus lambda 2. If we don't do the derivation, okay, I think some of you cannot see it. Now you can see it, right? So x plus y equals to n. This is Poisson. Okay, follows lambda 1 plus lambda 2. And x given this, x is actually lambda 1. Okay, so you want to calculate the expectation of x. Actually, it's n times lambda 1, and divided by lambda 1 plus lambda 2. This is a rate, right?
Excuse me. The sum of x and y is a certain number, so how can x and y be independent?
X, y can. That's the problem setting. X, y is independent Poisson random variable. Even if it's Poisson, you can find x and y. You add them together equals to n. You have x randomly independently variation, right? And y independently variation. Independent random variable. X has value, y have value. But you can find the moment that you have x, y, and plus them together equals to n, right? Am I making sense? So x plus y equals to n is the condition. Because x, y, although they are independent, they take different values. But you want to find out when x and y equals to n. And then you want to find out when x equals plus y equals to n, what is the expectation of x? Because x can take different values. Okay? Am I making sense? Good. It doesn't mean that they are independent and we cannot add them together. Okay? We can still add them together and form a condition. And then find out the expectation of x.